Good morning, class. Welcome to our business mathematics class. And for our fifth chapter, we're going to discuss interest and commission. And under that, we have three lessons that is basic concepts on interest, and commissions. And after completing this chapter, you will able to learn first illustrate how interest is computed specifically as applied to mortgage, amortization, and service utilities, and on deposit and loans. Second, illustrate the different types of commissions. Third, compute commissions on cash basis and commission on installment basis. Fourth, illustrate how to obtain down payment, gross balance, and current increased balance. And lastly, solve problems involving interest and commissions. For our first lesson, we're going to understand the basic concepts on interest. If you observe, in some occasions, we don't really pay cash whenever we purchase, right? So nowadays, most people are using postpaid connectivity in phones and internet, electricity consumption, water consumption, which are examples of using credit. Many of us prepare buying on credit at the department or grocery stores, using credit card on big purchases, or buying automobile or house and lot on installment plan. Before, credit was originally given as an additional service to hook customers and increase sales. Consumer credit nowadays is not just a service to the customer but an income generation to a company. So these companies give interest or finance charge for the credit used by the consumers. Two common types of loan are consumer and business loan. A consumer loan is given to retail customers or individuals for personal purposes. On the other hand, business loan is to lend companies or business enterprise to finance their businesses operating costs like corporate loan, commercial loan, small and medium enterprise loan, among others. Another type of loan is mortgage. This is a long-term loan. It is usually applied when purchasing a home, land, or a business, or when some money down and making requirements to pay the balance in monthly installments over the life of the loan. There are some types of mortgage, such as adjustable rate mortgage, variable rate mortgage, renegotiable rate mortgage, and to name a few, to compensate the lender preference in effort to dampen inflation. The difference in the new mortgage rates is that the interest rate are not fixed for the life of the loan and can be adjusted according to prevailing market rates of interest. In traditional mortgage, the monthly payment for the principal and interest over the life of the loan is constant. Since the interest is computed in the unpaid balance, the payments for the first several years are made up mostly on interest and small amount is deducted in the principal. So generally, the size of the monthly installment or the monthly payment depends on the size of the loan, the interest rates and the length of the loan. On the other hand, amortization is a financial arrangement whereby a lump sum is incurred at compound interest now, such as loan, and is liquidated or paid off or by a series of equal period payments for a specified amount of time. Example, monthly, quarterly, semi-annually, or annually, and etc. So amortization of loan is the repayment of a loan by period payments, with the possible exemption of the last payment equal in amount. These payments are often described as combined payments of principal and interest. When the debt is paid in series of periodic payments, pay the interest outstanding at the time the payments are made and also repay a part of the principal. As the principal is gradually reduced by periodic payments, the interest of the unpaid balance decreases. Amortization period, on the other hand, is the length of time over which a loan is scheduled to be fully repaid after the two parties, that is the lender and the borrower, agree on the amount of a loan, the rate of interest, and repayment frequency. After which, the amortization schedule will be established. An amortization schedule is a list of several periods of payment showing the principal and the interest parts of those payments and outstanding balance or your principal after each payment is made. Majority of the financing institution provided the borrower with an amortization schedule. The data of the amortization schedule are important to the borrower for two reasons. First, the borrower needs to know the total interest paid. And second, the borrower needs the data if he or she is planning of paying off the loan early. The repayment of the loan could save more money because advance payment would be all principal amounts and would not include any interest. But the financing institutions can possibly charge a repayment penalty that would absorb some or all of the interest savings. So, now we know the basic concept of interest. Let's proceed to the second lesson, that is interest. Type of interest that is most commonly calculated on short-term loans is simple interest. Simple interest is calculated only on the original principal amount and is paid at the end of the loan period. Interest is the fee or rent that the lender charged to borrowers for the temporary use of the borrowed money. The amount borrowed is called principal, and the rate of interest is the percentage of the principal that will be charged for specified period of time. Example, daily, weekly, yearly, and etc. These are the formula for the simple interest, where P stands for the principal amount of the loan or investment, R is your annual rate of simple interest, T is the time, period, or term of the loan or investment, I is the amount of interest paid or received, and F is the maturity value of the loan or investment. So this formula, we're going to use it on our examples. Under interest, we have the topic of determining the time period. To find the due date, we must determine the number of days in each month. Then we simply compute month by month the number of days from one date to another. The loan date is the first day of the loan, and due date, or what we call maturity date, is the last day of the loan. When these two dates are known, the number of days of the loan can be calculated using the days in each month. So as reflected here in this figure. Okay, so for the month of January, we have 31. For the month of February, if that is a leap year, we only have 29 days. So if not, we have 28 days. For the March, we have 31, April 30, 31 for May, June that is 30, July, that's 31, August 31, September 30, October 31, November 30, and December for 31. So we have the steps in solving the number of days of a loan. That is, first, identify the number of days remaining in the first month by subtracting the loan date from the number of days in that month. Second, write the number of days in each month. Third, write the number of days in the last month. Lastly, add the date from the first month to the last month. Under interest, we also need to determine the actual and approximate time. The time period, which is T, should be determined using the number of days involved. There are two ways of determining the time period. It can be approximately or actual time. An approximate time uses 30 days in every month, while the actual time uses the exact number of days in every specific month. Okay? So let's have examples on how do we determine the actual and approximate time. Let's have two examples in getting the actual and approximate time. So for question number 1, determine the actual and approximate time from March 3, 2015 and September 10, 2015. So for this question, we need to identify if 2015 is a leap year. And how do we determine if it is a leap year? It should be evenly divisible by 4. And since 2015 is not evenly distributed by 4, therefore we can say that this is not a leap year. So we have 365 days. Okay? So we're going to start with March 3, as said in the given 2015. Okay, so for March 3, we have 31 days. Remember, for the actual time, we use the exact number of days in every specific month. Okay, so 31 minus 3, it will give us 28 days. Okay, so next, April, May, June, July, August, and lastly, September 10, 2015. So here, meaning the end of this is 10. Okay? So how many days we have in April if we use the actual time? So April we have 30, May we have 31, June we have 30, July and August we have 31. And to get the actual time or days of this, we're going to add this. Okay, that will give us an answer of 191. While for the approximate time, we use 30 days in every month. Okay, so same as we did. So 30 minus 3, that will be equal to 27. And then all of the months will be 30 except for September 10, which says it is the end date, okay? And then we're going to add this. It will give us an answer of 187. So therefore, the actual time from March 3 to 2015 and September 10, 2015, that is 191. While the approximate time from March 3, 2015 and September 10, 2015, that is 187. Okay, let's have the example number 2. Find the actual and approximate time from November 2015 to May 9, 2016. Okay, we know that 2015 is not a leap year. However, 2016 is a leap year. Okay? So, we need to remember there will be February 29. Okay? So, let's put November 18, 2015. Okay. Next, we have December, January 2016, February, March, April, and lastly, May 9, 2016. Okay, same as we did. That November has a 30 days. So 30 minus 18, that will be equal to 12. December, we have 31 days. For the January, we also have 31. And since February 2016 is a leap year, that will be 29. Okay. Next, March, we have 31. April, we have 30, and lastly, May 9. So that will be 9. Getting the sum of this, it will give us an answer of 173. For the approximate time, remember, we always use 30, regardless if it is leap year or not. Okay, so 30 minus 18, that is 12. Then 30, 30, 30, 30, 30, and lastly, So getting the sum of this, it will give us an answer of 171. Okay? So therefore, there are 170 days, 173 days in actual time, while 171 days in approximate time. Under interest, we also have exact and ordinary interest. Exact interest is computed in a 365 days in a year as the time factor denominator. On the other hand, ordinary interest is a type of interest wherein the number of days is computed based on 360 days in a year. Mostly, banks and other institutions still use ordinary interest because it yields a somewhat higher interest as compared to exact interest method. If the type of the interest is not specified in any problem, the problem will be solved using the banker's rule or what we call ordinary interest in actual time. So this will be our formula. So for the exact interest, time is equal to number of days of a loan over 365 days. While for the ordinary interest, time is equal to number of days of a loan over 360. So remember, we use the actual and approximate time. So we find it out earlier. So now we're going to use it as well here in determining the exact and ordinary interest. So there are some notes that we need to consider. Rate must be converted to a decimal or fraction before substituting to any formula. Next, time period is computed in terms of years. Okay? This means that the time period expressed in months or days must be converted to a fraction of a year before being substituted into the formula for t unless stated otherwise. Okay, let's have examples on how do we find the exact and ordinary interest. Example number one, find the interest on 28,700 pesos at 7.3% from March 14, 2016 to August 16, 2016 using the following. First, ordinary interest using actual time, ordinary interest using approximate time, exact interest using actual time, and last, exact interest using approximate time. So first, we're going to identify what are your givens. Okay? So your givens are your principal amount of 28,700 pesos. And the rate of interest, which is 7.3. Or convert this into decimal, that will be 0.073. Okay? So, the first step is to determine the approximate and actual time of the term. Then, we're going to compute for the ordinary and exact interest. Okay? If we remember, we need to determine first if the time is leap year or not. So 2016 is divisible by 4. So therefore, we can say that this is a leap year. Okay? So let's put March 14, 2016. Next, April, May, June, July, and lastly, August 16, 2016. Okay, for the actual time, remember, we're going to use the specific days in a month. Okay, so for March, we have 31 minus 14, that will be equal to 17. For April, we have 30. May, we have 31. June, we have 30. And July, we have 31. And lastly, August until August 16. So, to make it easier, you can use the hand method. Okay? So, it will give us a sum of 155 days. While for the approximate time, remember, regardless of the month, regardless if it is leap year or not, we're going to use 30 days. Okay? So 30 minus 14, that will be 16. Then 30, 30, 30, 30. Lastly, 16. Okay? It will give us an answer of 152. Okay, so therefore we can say that there are 155 days for the actual time and 152 days for the approximate time. Now we can answer the first question. And if we recall, the formula for the interest is equal to interest principal times your rate times your time. Okay? So for A, we have ordinary interest using actual time. And for the exact interest, we're going to use the number of days of the loan over 365 days. Okay, so for letter A, that will be I, is equal to your principal rate, that is 28,700 pesos, multiply by your rate, that's 0.073, times 155 divided by 360. Okay, this is for your actual time, ordinary interest using your actual time. And getting the product of this, it will give us an answer of 900 pesos, 902 and 6 cents. Okay? Next, let's have ordinary interest using approximate time. So same, 28,700 multiply by your rate. So for this one, we're going to use 152 divide by 360. Okay? So it will give us a product of 884 and 60 cents. Okay, I'm going to put the formula for the ordinary interest for an exact interest. Okay, so for exact interest, we have number of days of a loan divided by, I hope you understand, okay, divided by 365. And for the ordinary interest is number of days of a loan, that is loan, over 360, which we used here, right? Next, let's compute for the exact interest using actual time. So same process, that will be 28,700 pesos multiplied by 0.073. So for this one, that is 155 divided by 365. So it will give us an answer of 889.70. Okay? And lastly, let's compute for the exact interest using approximate time. Okay? Times 0.073 times 152 divided by 365. That will give us a product of 872.48 cents. So, we can say that ordinary interest using actual time or the banker's rule provide the highest interest. Okay, if you can observe. Okay, while the lowest generated interest is exact interest using approximate time. So here, as you can see, This is the lowest and this is the highest. That's why most of the banks use the ordinary interest using actual time, or what we say, the bankers rule. Let's have example number 2. What amount should be paid on January 15, 2016 for a loan of 16,000 made on July 7, 2015 at 8% simple interest? So, using ordinary and exact interest, using actual and approximate time. Okay, so first we need to identify what are your givens. Okay, so we have a principal amount of 16,000 pesos. And we also have the annual rate, which is 8%. Convert this into decimal, that will be 0.08. And we're looking for the maturity value of the loan or investment. The formula for that is F is equal to your principal amount multiply by 1 plus rate times your time. Okay? So, the first step is to determine the actual and approximate time of the term. Then, we're going to compute for the amount using ordinary and exact interest. So, let's start with July 7, 2015. So, July 7, 2015. Next, we have August, September, October, November, December, and January 15, 2016. Regardless if it is leap year, we don't have the month of February. Okay, so in July, we have 31 days. So 31 minus 7, it will give us an answer of 24. August, we have 31 days. September 30. August, we have, October, we have 31. November 30. December 31. And lastly, we have January 15. Getting the sum of this, it will give us 192 days for the actual time. Next, let's compute for the approximate. That is 30 minus 7 is equals to 23. And then 30, 30, 30, 30, 30, 30. And lastly, 15. It will give us an answer of 188 days. So therefore, we have 192 days for the actual time and we have 188 days for the approximate time. Okay, let's proceed to each question. So, ordinary interest using actual time. Your formula again, that is 16,000 multiply by 1 plus 0.08. What is your actual time? That is 192. And we divide it by 360 since this is an ordinary interest. Solving all of this, it will give us 16,000 multiply by 1.042. We have 567. Okay. And the product for this is 16,682.67. So therefore, using the banker's rule, we can have an interest of 682 pesos and 67 cents. Okay? Next, let's compute for the ordinary interest using the approximate time. So same, that is 16,000 multiply by 1 plus 0.08 times, now we're going to use the 188 days over 360. Okay? So, 16,000 multiplied by 1.0477777. So, we have 578. Okay? This will give us an answer of 16,668 and 44 pesos. So next, exact interest using the actual time. Okay? So 16,001 plus 0.08. This time, we're going to use 365 days. So it will give us multiply by 1.04208219 will give us an answer of 16,673.32. And lastly, if you're going to compute for the exact interest using approximate time, using this formula and using this process, so we can have 16,000 multiplied by 1 point, let's bring it down, 1.041205479. That will be 16,659 and 29 cents. For our next topic, under interest, let's try to compute some simple interest problems. First example, what amount of interest will be charged on 7,300 pesos borrowed for 3 years at a simple interest rate of 12% per amount? So on your left side, these are the formulas that we are going to use. We're going to choose from, okay? So let's identify what are the givens. So we have a principal amount of 7,300 pesos. We also have the time, which is 3 years. Remember, if your given is months, days, we need to convert it into years. Okay? Next, we have the annual rate of simple interest. That is 12%, or in decimal, that is 0.12. So the question is, we need to find out what is the amount of interest. So the formula for that is your interest or amount of interest paid or received equals the principal amount of the loan or investment times the annual rate multiplied by the time period. Okay, so let's proceed with the solution. So I is equal to 7,300 pesos times, what is your rate? 0.12 times 3. Okay? And getting the product of this, it will give us an answer of 2,628 pesos. So your conclusion, the principal will earn an interest of 2,628 pesos. Second example, Maria paid 9,250 pesos on a loan made 6 months before at 12% simple interest. Find the interest generated. So for this question, we have the givens of the maturity value of the loan, of Maria's loan, that is 9,250 pesos. We also have the time. However, this is in 6 months. Remember, we need to convert this into years. So, in 1 year, we have 12 months, right? Okay, how do we convert months to years. So we need to divide. So 6 months multiply by 1 year divided by 12 months. And then remove this. So there will be 6 over 12, which will give us an answer of 0.50 years. Okay? Next, we have the rate of 12%. Convert this into decimal, that is 0.12. Now, so in this particular example, we were going to use the formula F is equal to P times 1 plus RT and solve in terms of P since we're looking for the interest generated or the principal amount. So, okay, and to find the P, okay, let's divide it by 1 plus RT. So we can cancel this out and it will give us a formula of P is equal to F over 1 plus RT. Okay? Let's now proceed to the solution. Okay. Substitution. So what's your maturity value? That is 9,250 pesos over 1 plus what is your rate? That is 0.12 times your time. That is 0.50. Okay? So, 1 plus, getting the product of this, it will give us an answer of 0.06. Therefore, 9,250 pesos divided by 1.06 is equal to 8,726.42. After obtaining the value of the principal, okay, we're not yet done because we're looking for the interest generated. We then compute for the interest using the formula. So, F is equal to P plus I. Okay? And then, since we're looking for the interest, it will be I is equal to your F minus your P. Okay? So, our next solution, I, your maturity value, 9,250 minus 8,726.42 pesos, that will be equal to 523.58 pesos. Okay? So, your conclusion, the interest will amount to 523 and 88 cents. Let's proceed to example number 3. If a 9-month term deposit at a bank has a simple interest rate of 9% per annum, how much will be deposited to earn 225 pesos of interest? Okay, so our given, first, we have a time of 9 months and then convert this into years, it will give us an answer of 0.75 years. Remember, we divide 9 by 12. Okay? Next, we have an interest rate of 9%. Convert this into decimal, that is 0.09. And lastly, we have an interest of 225 pesos. Now, the question is how much we need to deposit. So therefore, we're looking for the principal amount. Okay? And for the formula for that is P is equal to your I over RT. So this formula came from I is equal to PRT. And looking on your left side, using the magic triangle, so here, okay? So let's proceed to the solution. Substitution, that is 2,225 pesos over what is your rate, that is 0.09 multiply by your time, that is 0.75. Okay? 0.09 multiplied by 0.75 is equal to 0.0675, and 225 divided by 0.0675, that is 3,333.33 cents. So since this is money, we need two decimal places or the hundred place. Okay? So your conclusion, 3,333 pesos and 33 cents must be placed in the 9-month term deposit to earn 225 pesos of interest. Now, let's proceed to question number 4. What is the present value of 5,275 pesos due in 6 months if 11% interest is paid? So, for this question, we're looking for the principal amount or the present value. Okay? So, the given will be your maturity value of 5,275 pesos. Next, we have the time period, that is 6 months. Convert this into years, that will be equal to 0.50 years. Next is we have the rate or the annual rate of simple interest, that is 11%. Convert this into decimal, that is 0.11. And the formula that we're going to use, same as we did in the question number 2, that is F is equal to P1 plus RT. Since we're looking for the present value or the principal amount, the formula that we are going to use is P is equal to F over 1 plus RT. Okay, so solution, P equals to 5,275 pesos divided by 1 plus 0.11 multiplied by 0.50. So 5,275 pesos over 1 plus 0.055 or 1.055, it will give us an answer of 5 pesos. So your conclusion, the present value is 5,000 pesos. Let's proceed to example number 5. Aaron makes an investment by lending 24,000 to Bartolome for 2 years at an interest rate of 11% per annum. What is the maturity value of the investment? Okay, so our given, we have a principal amount of 24,000. This is the amount that Aaron lent to Bartolome. Next, we have the time period, which is 2 years. So no need to change this. This is already in years. Next, we also have the annual rate, which is 11% or 0.11. And we're looking for the maturity value. Okay? So our formula for that is F is equal to P times 1 plus RT. Okay, let's proceed to the solution. Substitution, your principal amount, 24,000, 1 plus multiply by 0.11 times 2. Okay, so 24,000 pesos multiply by 1.22. It will give us an answer of 29,280 pesos. Now, there is an alternative solution for this. So the maturity value can also be computed using the formula I is equal to P RT. So this is the first formula that we're going to use. Then followed by the formula of F is equal to P plus I, which we did on the previous example. Okay, so let's first solve for the interest. Times your rate, 0.11 times the time. So it will give us an interest of 5,280 pesos. And then once we get the interest, we can now substitute the formula. So F, that is your principal amount plus the interest. Okay? It will give us an answer of 29,200 pesos. So same answer we got. Okay. So therefore, your conclusion, Bartolome, Bartolome should pay Aaron 29,280 pesos. Now, let's proceed to the last example. Abel placed 18,000 in a 240-day term deposit, earning 8.5 per annum. How much will the bank pay Abel on the maturity date? Okay, so we have here the principal amount of 18,000. Okay? And for a time, we have 240 day. Remember, we need to change the time period into years. And to do that, we need to divide 240 over 360. Okay? Next, we also have the rate. That is 8 and a half percent. Or if we change this into decimal, it would be 0.085. So now we're looking for the maturity um value, okay, that the bank should pay Abel. Okay, so the formula for that will be F is equal to P times 1 plus RT. So solution, F is equal to 18,000 pesos multiplied by 1 plus 0.085 times 240 divided by 360. Now, you're going to question me why I didn't give the answer for this, because it will give you lots of decimal numbers. Okay? So, you can try it on your calculators. So, 18,000 multiply by 1.05. So we have here 2, 4, 6, 6, 1, 2, 3, 4, 5, 6, 7. That will give us an answer of 19,020 pesos. So therefore, the bank should pay a bill 19,020 pesos.